Lesson 3.3 connects us to something back from Chapter 2. We're going to take a look at systems of linear inequalities. A system of linear inequalities is just like a system of equations, except we have inequalities. As we graph each individual inequality and shade, the solution comes from the overlap of each individual inequality. And we just want to make sure that that's super clear that that's our solution. Make sure to darken that in clearly to show that that's where the two solutions or three solutions in the system overlaps. Let's take a look at some examples on the right. The first system, y is greater than negative 2x minus 5, and y is less than or equal to x plus 3. We want to find on our coordinate system where those two inequalities overlap. Let's start by sketching y is greater than negative 2x minus 5. Go ahead and pause the video and see if you can graph and shade that first inequality. Then press play and we'll move to the second one. Okay, how did that first one go? Notice it's a negative slope, so from left to right the line falls. Because it's just greater than, we have to use a dashed boundary. And when I checked 0, 0, 0 on the left is greater than negative 2 times 0 minus 5 on the right. That's a true statement, meaning I shaded on that far right side on the coordinate system. All right, let's do the same thing. Pause and graph the next inequality, and we'll see what happens there. I noticed for y is less than or equal to x plus 3, once I knew where my points were, I sketched my boundary line with a solid boundary, and if y is less than or equal, I shaded below that blue line. Now you'll notice there's some significant overlap between the red and the blue. That overlap then is the solution to the entire system. What I'm going to do to make that solution clear is just darken that total solution in. Now, some students like to just shade the overlap. They sketch each individual inequality and they just shade that solution. They erase the other part. As long as you are confident in that process, I'm okay with that. What this answer means is that any ordered pair in that darkened region would make both of the inequalities in the system true at the same time. Now, both of those forms were in slope-intercept. Over here on the next one, we're going to change it up a little bit. The first inequality in this system is in that general or standard form. 2x plus 3y is less than 6. What I would do is convert that first one to that slope-intercept kind of idea before we start to graph it. To do so, I'm going to subtract 2x. Well, first I'm just going to rewrite it. 2x plus 3y is less than 6. Now, it's important to show the operation. I'm noticing on assessments when students are not showing how to move things over, even though it seems like it's pretty easy to do, we're missing the positives and negatives, and that would make a significant difference on our graph. So just be careful as you do this process. I'm going to divide both sides by 3, and this will ultimately get y by itself. Now remember, we have to do the slope first, so negative 2/3 x. And then plus, I have to do the other side for my y-intercept. 6 divided by 3 is 2. All right, now that we have it in that slope-intercept form, go ahead and pause the video and let's sketch that graph. Press play when you're done. Next, we're recognizing that it's just less than. I used a dashed boundary for my line, and then y is less than, I shaded below the line. All right, let's go ahead and do that last one. Y is greater than or equal to negative 2/3 x plus 4. Again, pause the video, sketch it, and then press play. You may have recognized in both of those linear inequalities that the slopes were the same. They were both negative 2/3. As I sketched the graph for the bottom inequality, I used a boundary line that was solid because it's greater than or equal. And then when I shaded, I noticed that the shading went in opposite directions for both of them. So as we think about what could the possible solution be, here's something to recognize. If there's no overlap, that means there isn't a single ordered pair that works for both inequalities at the same time. No overlap means no solution. And there you go. Let's try the two at the bottom. All right, let's take a look at this one, everybody. We have 3 linear inequalities to sketch the graph for. Y is less than or equal to x is less than 2, and 2x minus 3y is less than or equal to 3. I'm going to start with y is less than or equal to x first, and I'm actually going to write this one out with you because sometimes this one gets a little tricky. If you recall from chapter 2, this is one of the parent functions. What this means is technically the slope for x is 1 and the y-intercept is 0. Now, if you remembered that, that's awesome. But sometimes this one gets missed with students just because there aren't any numbers that you can see in that inequality. So what that means is I'm simply going to start at 0 and then go up 1 over 1, all the way to the top and all the way to the bottom. So go ahead and do the same thing. And then we're going to use a solid boundary as we connect all those dots. We'll go all the way through. So it's essentially cutting my graph diagonally into 2 parts, like so. And if we want y is less than or equal, that means we want everything below that line. So we're going to have to do a fair amount of shading here because we have 2 other inequalities that we're trying to match with. I know, it's kind of fun to just take some time and color. There we go. All right. So now that we have that first inequality graphed, let's take a look at x is less than 2. Now, anytime there's just one variable, that's going to indicate a vertical or a horizontal boundary. Anything with x is vertical. So I'm going to go to 2 on the x-axis and put a dot. If I have a vertical boundary and it's just less than, we have to use a dashed line. So let's go ahead and draw that dashed vertical boundary going through 2 on the x-axis, arrows at the bottom and the top. And if we want less than, that means we're going to shade to the left. That's when values on the x-axis are less than 2. So we're just going to lightly shade all of that in, like so. I know, we're getting kind of a mess here. All right, let's take a look at that last one. 2x minus 3y is less than or equal to 3. Again, this is one of those scenarios kind of like up above. We need to make sure that we get y by itself, and let's show the appropriate steps. And here, notice, if you move the 2x over, it's still negative 3y. So that's going to be interesting when we get y by itself. If I have negative 2x plus 3 on the right, when we divide by a negative, does anybody recall what happens to our inequality? If you remember that it switches direction, you are spot on. Very good. Now, negative 2x over negative 3 becomes positive 2/3 as our slope. And positive 3 divided by negative 3 becomes negative 1 when we plot our y-intercept. All right, now go ahead and pause the video, graph this inequality, and let's see if we can determine where all 3 have any overlap. Okay, so I didn't fully finish this question. I just graphed that line. Notice there's kind of like stuff happening all over the place. If y is greater than or equal to 2/3 x minus 1, that means I need to shade above my solid green boundary. When I do that, I don't get a lot of overlap there, but then all of a sudden there's kind of a small amount of overlap in there, and then it kind of continues on in this direction. So what that indicates, can you guys see where all 3, the red, the blue, and the green overlap? It really only creates a triangle like right in here, up here, and then a dashed boundary right here for the blue. So it's just kind of a little triangle shape right in the middle. Only the ordered pairs in that section make all 3 inequalities true at the same time. It's important to be careful as you're sketching your boundary lines because you can see here our solution's pretty small. All right, let's do that last problem on the right. For our last system, I have y is less than or equal to negative 3 and y is greater than negative 4. Now, because it's just one variable and it's y, these are both going to be horizontal. I'm going to graph y is less than or equal to negative 3 first, meaning I'll count down to negative 3 on the y-axis, and I'm just going to put a dot. Recognizing that it's less than or equal, I'm going to use a solid boundary line and go straight across, making that horizontal boundary. And then less than means we're going to shade below. So I'm just going to slightly go in through here and shade everything on the bottom half of that graph. And then I'll do the next one. Same idea, y is greater than negative 4, another horizontal boundary. So I'm going to go down to negative 4, just one below, but now it's greater than, meaning I'm going to have a dashed boundary. These are super close together, like so. But greater than means I'm going to shade above. All right, so just try to make that happen. Oh boy. Can you see where the overlap is, hopefully? Trying to make it so I don't get too crazy with my lines here. It looks like they overlap just in between the 2 inequality shaded areas. So that means our solution's just going to be this tiny little section right in here. And there's graphing systems of linear inequalities. And that's going to be it for lesson 3.3. On the back, we're not going to do the working backwards part, partially because they have those absolute value inequalities graphed and we didn't cover absolute value. And on your assignment today, I don't have you do that any of the work backwards. So this is it for 3.3.